video is for the answers to Chapter 5 test in geometry. So here we go. Let's see. We're going to start on page 1. And we started with this picture here. And one of the things I'm going to do throughout here is whenever I see a term like this, centroid or orthocenter, incenter, I'm going to start by writing down what I think the line that's used. And so for this one, it's the median. And since this was an open note test, I would encourage you to do that as well if you need to retake. So if FG, if FG is a median line, and we know that this is 12, what we know about the ratio here of this portion, this is 2/3 of the line, and this is 1/3 of the line. So that means that this is together going to be a measure of 18. The measure of GC, we also know that a median by definition is going from the midpoint of a side to a vertex, and so that we know that this has to be 9 units because GC and GD are equal. Based on the given, is FG the perpendicular bisector? No, it actually is just the median. And then we look at this, so we would say no to this guy. And then is GF? Well, GF is just the median. So then we move on to the next questions. So again, it's really critical, I think, for you guys when you take this test, is you know what line is involved with it. So if we talk about incenter, this is going to be angle bisectors. So we need to know, well, that's going to be important information for us as we get into this guy. So in this question, we had all the givens here listed in case you couldn't see what side they went with. And so what's the measure of HF? Well, this first side here, this one's a little tricky to see, but basically you have a right triangle. And so we're going to use a squared plus b squared equals c squared. And the a we don't know, plus the 24 we do know, and it's going to equal 25 squared. What happens is you're going to end up with this a squared is equal to 49, or a is equal to 7. When we get to GH, well, GH is just another, the angle bisectors all meet at this point H. And then, so what that means is all of these little lines here are the same distance. In fact, they're all the radius of a little circle here. So this guy's 7 as well. HCF, some people kind of got tricked on this one a little bit. And what this is saying is this guy and this angle, since the point's made by angle bisectors, this angle C just has to be 28 degrees. Because the bigger angle has been cut into 2 pieces. And what's the measure of FHC? FHC, well, I know that this is 90 degrees here, and so to get to this angle we just take 180 and we subtract 28, and then we subtract 90 from it. So I think that's 62 is what it shakes out to be. And then we move on. So as I move on to question 9, TQR, well, this is just basically saying that we're going to have the same angle here because these two triangles end up becoming similar. And there was a theorem that we studied at the beginning of, there was a theorem that kind of talks about this, especially when we're talking about angle bisectors. But this is 43 degrees, and to find x, well, to find x, we actually want this x, not this guy, but we want the variable here, and these two things are going to be equal to each other. Because the shortest point from this line to this side and this side is going to be a perpendicular line as indicated. And since this angle is the same as this angle, these two values are going to be the same. And you're going to evaluate it, and I think what happens is you get x is equal to 6. So 3x plus 5 equals 5x minus 7. Now the next section is really, I would have accepted either answer as long as you explained your answer. Now, if point D is the centroid, so if we accept that this is the centroid, and the centroid again is the medians, where the medians meet, what conclusion can we make between the line segment AD and line segment AE? Well, we can say this is probably the weakest answer. AD is going to be shorter than AE. That's certainly true. We could say that AD is equal to 2/3 of AE. I think this is probably the best, and I don't even think I would give credit for this one because this is just looking at the picture and going, well, this is shorter, so clearly, but this is using the definition of the centroid. Or you could have asked something along those lines. If you went the other route and you said there's nothing you could say about it and you explained why you believe that to be true, as long as you were detailed in your reasoning, I accepted it. So some of the counterpoints would be, we don't know for sure that this is the median line because we don't have a given that these are the midpoint. So I totally get where you're going on that. Next one, in-center. Well, the in-center is angle bisectors. And I accepted both sides on this. Now, what's missing from this, just to be a slam dunk, is if this had been a right angle and this had been a right angle, then I think you probably could have for sure answered the question that it's just 10. But I accepted it. Some people said there's no indication that FD is in fact a right angle, and that's a very valid point. So I would have accepted yes, you can find the answer, it's 10, and this is, you found it because these are the same distance, but I also accepted no if you said there wasn't enough provided in the givens. So I'm going to pause here. And I think we're back. We'll see here. Okay. So now with this, we're on to the third and fourth pages. So then it says if D is the circumcenter, and we know that that is from perpendicular bisectors, and that ABCDE is 10, so this guy is 10 units, and that DAB DAB is 40. Do you have enough to find out what DAE is? Can you find this guy? And the thing is, you can't. There's just no way to go about it. There's just not enough information. And so the answer is no, and there's really no way to find that information unless you found a way. And if you did, push back on this, but I don't think you can. So then the next thing, the next question, this one, we again could have gone either way. It's 10 units here. That's actually information you didn't need. DAE is the 40-degree angle right there. And by definition, if this is the orthocenter, then this is 90 degrees. So you could find that it's 50 degrees. But I didn't put those right angles in. So you could say, well, wait a second. I don't believe that that is actually the shortest distance from D to E. I think it would have been over a little bit. And if you went that route, I accepted that answer as well. The proof, let's see. I think I provided some information here, but I think I had a whole bunch of givens. And then we went to, I think we started talking about these angles here. So if we said that the angle FAH, we said it was congruent to angle BAH, and we could have done anything such as definition of an in-center is made up of angle bisectors. So angle bisectors would have also worked. And then we had this other given in here, AF is to AB, so this is going to come into play here in just a second. That was already in the dot dot dots. And then we also have AH is congruent to AH, and that's going to be the reflexive property. I can't even write. Alright, so the reflexive property. Now I think at this point we have side angle side. So I know we've got our two triangles, and so we go ahead and say that triangle FAH is going to be congruent to triangle BAH. And the reason why I'm making these triangles congruent is I'm going back to my prove line. My prove line says I got to get these guys right here congruent, and the only way I'm ever going to get that, unless it says midpoint somewhere, I'm going to have to use CPCTC. So HF is congruent to BH, and that's CPCTC. And then I think the last one was just to drop it into in terms of equality, and that is just definition of congruency. We can flip-flop between the two. All right, we'll pause again and get to that last page. Okay, the final page. We got here, and let's see, using the drawing above for the following two questions. Okay, what's the smallest side? Well, first we need to have this angle, and it looks like this angle is 20 because the three angles need to add up to 180. So what's the smallest side? Well, it has to be the side that's opposite of the smallest angle, so it's going to be side AC, and the largest side is going to be the side opposite of this 120, so that's going to be AB. A couple people got tricked up on 3 and 4. Really what we're asking you to think about is, does 3 plus 4, is it greater than 6? Yep. Is 3 plus 6 greater than 4? Yep. And is 4 plus 6 greater than 3? Check. Yes, this could be a triangle. It's not going to be a right triangle. Some people wanted to argue about the right triangle. I get where you're going on that, but I didn't ask if it was a right triangle. I just asked if it could be a triangle. So both of these are going to end up being the same answer. And this one, again, if you just add these two together, are still bigger than the biggest side, and it's going to be the same thing. You pick all three combinations. And then finally the last thing, and this is looking at angle B and angle E. Well, angle B opens up to side 10, angle E opens up to side 18, and all the other sides, the other sides are the same. So angle B must be less than angle E. Alright, I hope this walkthrough helped, because really this video is designed if you had questions about the test, but also if you need to retake the test. You've kind of seen a walkthrough. Some of the things I noticed is that definitions are really what hurt people. Knowing what lines make up the different points will really help you when you retake it. And then I think also just a general review of proofs. When would you use CPCTC and when would you use SAS, or any of those combinations of S and A to prove triangles congruent. I hope this helped. If it didn't, if you have questions, please email me or talk with me individually. Thanks so much. Have a wonderful day.